Today, Professor Fabio Sgarbossa will present Innovation in Logistic 4. Fabio is professor in industrial logistics, leader of the production management and logistic groups, and responsible of the Logistic 4 lab at NTNU. His research focuses on various topics in industrial logistics, for example, design, management of industrial logistics systems, technological innovation, material handling, but also human-centric design, additive manufacturing, hydrogen supply chain, and similar. He's also the chair of IFAC, Industrial Federation of Automatic Control, and he's chairing Technical Committee 5.2 in Management and Control in Manufacturing and Logistics. And he's also the organizer of IFAC 2025 in Trondheim. Today, Fabio will present how Logistic 4 Lab is used to generate new research ideas and successful collaboration with national and international partners. The floor is yours, Fabio.
Thank you very much. Of course, I start with, can you hear me well? And do you see my slides?
Yes.
Good. So thank you very much, Alenka. Thank you very much, Mara, for organizing this. I will start with some questions, and then we go into what we do in the Logistic 4.0 lab. So let me see. Okay, so what are these activities? These activities are activities that we do every single day, more or less. But all of us are quite familiar with the grocery shopping, moving to a new home, event planning. I mean, we are everyone planning the Julebur now. Travel planning, maybe someone is going for a holiday somewhere for a Christmas holiday. Online shopping, I mean, last week was the Black Week. Meal planning, every day we have to eat. We come to work, but also we do some home repairs and renovation. But why I'm saying this? Because these are activities that typically logistic people do. In fact, logistics is the process of planning, implementing, and control the efficient, effective forward and reverse flow production and the storage of goods service in order to meet basically the customer demand. So when we talk about logistics, we talk about everything from that you need to satisfy a specific demand from a customer. So from buying the raw material, producing the products, distributing the products, putting the products on a store or online, but also the return aspect, so the reverse flow. That can be just because the customer doesn't like the product, or just because you have to dispose the products at the end, or you need to reuse the products in some way. So this is logistic, and we know very well what is logistic because we experience that every single day. So it's nothing new, it's not rocket science, but it's an important part of our life, and in particular for the industry is super important to have efficient and effective system and a way of manage this. On the other side, we are surrounded by technologies. We have mobile robots everywhere. We control our TV or our screen or our washing machine with our phone. We do basically data analytics when we watch sport games. We visit in virtual mode places, and we are basically very well into the sharing economy and all the online platform to share resources, etc. So this is what is the starting point for my speech. So we know exactly what is logistic, and we know exactly that we are surrounded by technologies. But who I am Fabio Sgarbossa. I'm in Trondheim since 2018. I'm professor of industrial logistics. My background is more on industrial engineering, management engineering from University of Padova in Italy. So I'm Italian. We are so creative, and I'm moving my creativity, my culture into my work, and I like that because here at NTNU I can do easily this job. My research interest, as Alenka introduced when she introduced me, basically varied from industrial logistics, material handling, production, but also supply chain design, maintenance, etc. in many different fields. I'm leading the production management research group at the Department of Mechanical and Industrial Engineering, where with a group of more or less 15 people, we work around creating knowledge and applying research in sustainable industrial logistic operations. So we like to group this into two clusters for the logistic inside the factory. So what you do inside the factory, from facility planning, the decision about technologies, but also the day-by-day operations, to a supply chain level. So the coordination, the collaboration with the actors along the supply chain, so your suppliers, but also your distributors, how to distribute the product, how to forecast the demand from the customers, etc. And whereas our technologies play an important role in this and can help the managers and the decision makers to collect the data and make more accurate and timely decisions. So for us, our goal is to help the decision makers, so the managers, the engineers, to design, planning, and control industrial systems. Thanks to the department, we have a very good laboratory, which is the Logistic 4.0 lab, which was in Valgrinda, but from this year is fully operating here in Perleporten, or here in Glossagen. And we use basically the lab to replicate some activities in a production and logistics system, mainly for the intralogistics. For the supply chain, so what is inside the factory. For the supply chain, we have typically some simulation software that we use, and we use the equipment that we have in the lab in many of the projects that we have, going from like circular manufacturing, the catapult, Norsk catapult with E-Kuben in Molde, the EAT manufacturing design for human-centric design of a production system. Smart Lib will be one, I will talk about this a couple of minutes during this presentation. So how to do smart logistics in the library sector. H2 Glass is a European project where we study in our case, in our work package, the digital twin of production of glass, where hydrogen is the fuel. FutureLog is more an international partnership project around sustainability in logistics. Digimat is more on food supply chain, and Lean 4.0 is more about applying lean manufacturing principle supported by the Industry 4.0 technology. We do research in the Logistic 4.0 lab. We do collaboration with the companies, and we do education in this lab. So the idea is to use the lab to generate activities in collaboration with the companies, with the students and the researchers. We like to say that we do not develop the technology, but we are the user of the technology. So as I said before, for us, the main user of our knowledge, of our research, is the decision maker. So for us, it's important that the production manager, the facility manager, the logistic manager can understand or will understand the use of these technologies and how these technologies can change the way they produce, the way they design a system, the way they manage the system, etc. I'm going to present 3 examples as you see here, there are just some example of projects and application that we have in the lab. So we have tens of these examples. I will pick just 3 because I think they build up also why we have an innovation project in the public sector with the Trondheim Public Library. But if you want to know more about the other activities in the lab, just feel free to contact me. Yeah, I can open also. I mean, the lab is always open, so you can come and visit me whenever you want. So through these examples, I wanted to show you some of the examples of the application and the things that we developed in the lab, but also the way of how we created this, how we came out with these questions. Why? Because basically we are, as I said, we are surrounded by, we are into the technologies. We have technologies everywhere, so we like to see how technology can help in creating new logistics system, but also develop a new way of handling these logistics systems. So starting from the first one, which is the Cloud Material Handling System, CMHS, we start from the comparison between the material handling equipment. So the material handling equipment are the typical, forklift or vehicles that you use to move things in a factory that can be completely manual or can be completely automated. Of course, they have different pros and cons. So our question was, is there any other option out of this? So we looked, this started 3-4 years ago, actually was during COVID. So we, in the group and with also some students, we start thinking about any other option about this. And we came out with this line of reasoning. So if you remember, or I think many of you started traveling and driving with a paper map, right? So you plan your trip from A to B, and then you use the map to go from one point to another. And then, of course, Google Map came, and basically you don't think about how to plan to go from one point to another. You just put the Google Map and just follow the instruction by Google Map. But still, you are using your car, you are using your vehicle. Of course, the recent development is the Uber or this type of solutions, where basically you just put the indication of where you would like to go, and then someone will pick you up and bring you to the final destination. But why Uber works and why also Google Maps works? Because of course you have a kind of, you are geolocalized, you use your phone to geolocalize where you are. The driver use their phone and their app to see where they are. So there is some kind of use of this data. So our idea was, can we use a similar concept for interlogistics, so for moving products inside the facility and then also at the supply chain level? So in our lab, we have an indoor positioning technology that is basically the GPS that you can use for indoor location. So you can geolocalize in a closed area, an active tag. So you can use this in order to have real-time monitoring, for example, of resources like forklift or pallets, but also do other type of analysis like heat map, congestion analysis, but also some kind of value stream mapping, etc. So basically, we have the technologies enabling this potential application of Uber for interlogistics. So we developed first with some students and then with the PhD student this concept of cloud material handling system. which is basically Uber applied for intralogistics, where the different products, the objects are the customer, in that case, in the Uber case, and the vehicles and the material handling equipment are the drivers in the Uber case. And then, of course, they communicate through a kind of cloud, or we call it intelligent cognitive engine, where basically we have some kind of algorithm that can allocate the requirements from the smart object to the available resources or vehicles, etc. So this is the first example of how we create a new concept, a new idea, and we are still working on this, applying also the deep reinforcement learning in order to have a better allocation of orders to the different vehicles or resources. Another example is this warehouse robotics. So I don't know how much you know about about warehousing and about robotics, but basically when you think about a warehouse, think about when you go to IKEA and you are in the final place, not when you buy the hot dog, but when you before the cashier, when you pick up your products from the warehouse. Warehouses are everywhere, right? In any supply chain, you have warehouses, and there is a need of more compact and responsive storage system for online retailing, for example, e-commerce, but in general for distribution networks. So there are many different type of warehouses. If we look at the more advanced type of warehousing, like where you have some kind of automation and robotization of that, we have some example here, like AutoStore, which is a Norwegian product. This robot arm is called Grab, which is another Norwegian product by Solver. But there are other robotics solutions like Magazino or Locus Game. But the most famous, the most popular when you think about warehouse robotics is the Kiva system or the Amazon system. So what you see here in the robotic mobile fulfillment system, where you move the racks with the mobile robots around the facility. On the other side, they are developing some concept starting or some application of a puzzle-based storage system, starting from what is the 15 puzzle game, where in this case you have a very high density, so you have just one free space, but of course to move out the different cells, you have to move quite a lot of cells. So with the master student and thanks to the collaboration we have with Wilmi, which is another Norwegian company. This is why I like to be in Norway, because we have a lot of these crazy people inventing this type of products. We were thinking, how can we use the wheels in this type of setting? So Wilmi, they introduced this autonomous wheel that they can mount in yeah, as you can see in the video, they can be mounted in many different objects, like like simple container or just shelves and so on. And they can be moved to any direction, and they are very smart. So we said, how can we do this for warehousing? So we came out with this solution where we basically, the idea, and it's still in the concept of proof of concept type of level, is to put the wheels, as is in this video, in a shelf. So instead of using the mobile robots, like in this case, instead of using mobile robots to move the shelf, like in the Amazon type of system, we use the the mobile robots to create this type of solution. So an advanced puzzle-based system that we call the puzzle-based movable rack system. Moreover, in addition, basically the advancement is also that with WheelMe, you can move to any direction. So you don't move just as in the puzzle game, just horizontally or vertically. You can move also diagonally. So you have basically you can gain up to 20% of the time on the speed of using this solution, of course, reducing a little bit the density, the storage density. So we are working on this with one PhD now. And actually, I'm happy to say that the master student who started this, he is working in WheelMe as an engineer there. All of this basically brought us to have a project with the Trondheim Public Library. So we got a project last year, is in innovation, is called SmartLib, is an innovation project in the public sector, where the Trondheim Public Library is the leader of the project, and we, with the Logistic 4.0 Lab and WheelMe, are the partners, and we have also the Filkes Bibliothek. Here, the goal is to use the data that you collect from the material handling system, from the information system, in order to free time of people in the library, so they can serve the patrons in a more efficient way, and don't spend the time to move books around. Just to give you an example, just to give you some numbers, the library move around 1 million books per year, and they organize more than 1,000 events per year. So moving books are not value-added activities. Organizing events and serving the community is what is bringing value to the society. So they wanted to focus on that. And through this, basically what we are doing is to introduce, for example, WheelMe or other smart material handling solution like mobile robots to move books around. So probably soon you will see some of these in the Trondheim Public Library in the city center. But also have some predictive analysis on how to distribute the books, how to make the books available to, they can mount in how to serve in a better way the patrons. So concluding, I want to say that logistic is everywhere. Of course, logistic is also rationality, efficiency, logic, but is also flexibility, agility, and consumer-oriented. So how we can innovate in logistic? We can innovate in logistic first starting being systematic and holistic. So looking at the global picture, not just one part, because what you decide in one part influence your customers, influence your suppliers, etc. On the other side, be a little bit nerd and a tech fanatic, I would say, because sometimes technology can help you, but not always. So don't start from the technology, start from the problem, and be curious and creative. So try to explore different fields. Look at how they do in other fields, and then try to understand if you can experimenting new solutions in your specific field. And of course, be uncomfortable. That basically brings you to find a new solution for your logistic problem. Thank you for your attention. If you have any question, I'm here.
Thank you, Fabio, for a very good presentation. We can extend for some minutes, but not longer than that. Any comments or questions, please?